Origami Math Genius is a curriculum developed for integrating art and science in education, K to 12. When I look at this beautiful origami art, I thought, oh, this is so elegant, but little did I know it was designed mathematically on the computers. And that's my inspiration. And the math design of origami art really turned me on. So I decided to develop a curriculum of Origami Math Genius. And we hope that it can help kids to overcome the math anxiety and excite them about learning. And what is the origami math? Okay, given any 2 points on a piece of paper, you can fold a unique line that passes through both points. Origami math is basically to define them mathematically. And for this one, we know it can be easily defined because 2 points define a line. So this particular fold can also be formulated mathematically into equation. Origami has only 7 basic folds. All of them can be formulated mathematically in equations. So that's the foundation of origami math. And origami has its own language called the folding diagram. It is a graphical instruction of constructing an origami art. And all this folding can actually be done mathematically on computers. So that's my what I found is very interesting. And if you look at this, the math folding on the computer, particularly if you look at the diagram, it's nothing but a simple math concept such as the geometry and fraction. So that's nothing difficult beyond a middle school kid. So origami solves problem too. For example, the airbag uses origami concept for the design, for folding design, and the computer simulation to ensure the deployment would happen in milliseconds to save life. So this is about life and death. Another example is a stand. They also use origami design so that the stand has to be narrow enough to travel within the artery, and then at the blockage, open it up and clear the blockage. So this shows how important origami is. Next example is a solar panel in a spacecraft. And it uses origami concept to pack them so small during the flight. And then when they reach the destination, they can open up and absorb, collect the solar energy. So there are many other applications. And this one, I used the origami math to design this fashion. So I told the model, this is a paper dress. Please don't smoke. So we had a great time and in the fashion show. And when kids learn the origami, you know, when they are having fun and when they are active, they tend to learn better. Origami math has been brought into classroom and research program in Harvard, MIT, Caltech, and the top universities. So I developed the OMG is to prepare our kids for the future. And here's an example of the OMG class. Okay, fraction is basic, the math concept for 6-year-old kids. So we teach them to fold a square of paper into half in different ways. So this is very simple. It's visual. It's very easy. And what about the 1/3 fraction? This is a classic math problem. You fold half first, and then fold the one corner to the half point. The intercepting point of the 2 edges on the top is exactly 1/3. So that just divided a square into 3 equal parts. In trigonometry, 45 degree is often used. But how big is 45 degree? You just fold a square paper into half. That reinforces the concept of the fraction, dividing 90 degree into 45 degree. So it's very easy. And what about the 30 degree? For the 30 degree, okay, you first fold half in the middle vertically, and then fold another corner to the center line. And this fold just trisect 90-degree angle into 3 equal parts, which is 30 degree. You can also fold this way for 60 degree. So this is just another example. And also fold a cube help develop the kids the 3D spatial intelligence. So by folding a cube, they learned it has 6 faces. So this is a modular origami. And we folded the tube also to construct a bigger project. So this is installation art using that cube that we fold. And it compels kids to plan the supply and calculate the number and the size of the cube used to construct this origami chimney. So this is, I think, is a really great project. Next is fold circular pie, but the gap was designed to compel kids to ask the question and to understand the relationship between a square and the circle, and then complete the gap. So this is just another example. Finally, example is the fold or computer design. This is maybe for older kids, and they can design the head profile on the computer, and then print out the diagram and then fold into a paper head. So, and we have designed quite a few projects like this. Finally, I want to say that OMG is really prepared for the kids and for our future. So I appreciate your attention. Thank you.